Hello, I am Sharad Shukla. Today we intend to discuss a very important topic from coordination chemistry, that is a crystal field theory. We are going to check the calculation of CFSE as well as the splitting of d orbitals in presence of octahedral complexes, and you will be able to understand the tetrahedral complexes by your own after getting this video. So firstly we will check the orientation of d orbitals. So there are 5 orbitals present in d orbital, as you are already aware. So let's check their orientation. In these 5 orbitals, these 3 that are called T2G are in between the axis, dzx, dyz, dxy. These are in between the axis, and 2 that are called EZ are on the axis, that are dx square, y square, dz square. For the splitting, it is must to keep remember that T2G is in between the axis while EZ is on the axis. Let's check the splitting in octahedral complex. So splitting in the octahedral complexes, keep remember in the octahedral complexes the ligand approaches along the axis. So which orbitals were along the axis? They EZ were along the axis, because you know the shape of octahedral is this. This is a plane, ligand, 4 ligands on the plane, one is above the plane, one is below the plane. So ligand is approaching along the axis. So what happens is EZ orbitals are along the axis. So let's say these are the 5 orbitals, degenerate d orbitals of metal atom. Then the ligand is approaching, the d orbitals have increased their energy. Then since the ligand in presence of ligand they have increased their energy, since the ligand is approaching along the axis. So EZ were along the axis, so you can see EZ is increasing their energy, right, getting destabilized, and T2Z are decreasing their energy, getting stabilized, because the ligand is approaching along the axis only. Now since T2Z is decreasing the energy, so the energy change will be negative, right, decreasing the energy. And 2 by 5 delta is showing energy change, and O is for octahedral. You will calculate it 5 for the 20 to 0.4 delta O. The energy will be decreased by this amount, energy gap, right. What happens, the destabilization, it is positive sign, energy is increased 3 by 5, and you will calculate 0.6. Later on I will discuss why this 3 by 5 and 2 by 5. You can see 5 orbitals and 3, total 3 by 5 and 2 by 5 also. So what happens in the tetrahedral complexes? In the tetrahedral complexes, ligands does not approach along the axis, ligand approach in between the axis. So which orbitals were in between the axis? The orbitals T2G were in between the axis. So what happens is, this time T2Z will increase the energy while EZ will decrease the energy. So what will be the energy change for EZ? What was for EZ? Plus 3 by 5. Here what will happen for EZ? It will be minus 3 by 5 delta O, because this time this is decrement in the energy, right, and it will be minus 0.6 delta O, getting stabilized. What was for these 3 T2Z energy gap? Minus 2 by 5, it was decrement with the negative sign. Now it is increasing, right, so it will be plus 2 by 5 positive 0.4 sorry delta O. Alright, so in this way this will help you to. And one more thing, over here we will write E, not the Z. For the tetrahedral complex we write only E, not the G, and this we will write T2, not the G. We have written T2G and EZ. Over here we will write T2 and E. And one more thing, these values, that is plus 0.4 delta O, minus 0.6 delta O, these will help you in the calculation of CFSE. So you need to keep remember this value. Positive negative sign to keep remember is very easy. What the most important thing to keep remember is, in the octahedral complexes EZ will increase the energy, and in tetrahedral complexes EZ will decrease the energy. E will decrease the energy due to the orientation of the ligand. Thank you.